Hello everybody, and welcome to the next video for the course. In this video I just want to tie up a couple of loose ends from last time. So declaration and initialization are just tying up some loose ends from last time, and then introduce you to three new data types: bool, char, and string. So recall what we've done so far. We've defined the data types int, long, float, and double. These are all numeric data types. That is, they are designed as storage spaces for numbers. So int and long are for whole numbers, integers. Float and double are for decimals. The difference between long and int is that long has more memory associated with it, so it is designed for big numbers. Okay, but in any case, we've only seen four data types, and they are all designed to store numbers. So this time, we'll talk about other data types, in particular these three. So what kind of thing are they storing? They are not storing numbers. They're storing other things. So let me just quickly tie up some stuff from last time. So if you want to create three integer variables with names A, B, and C, here's one way to do it. Three separate lines of code, each line declaring a single variable. That's about 3 times as much information as you have to write, though. Okay, so you don't actually need 3 lines of code. You can use a single line of code like this. So just separate the names with commas, and then when you're done listing them, use a semicolon. So this does the same thing as these 3 lines up here. It just creates 3 storage spaces for integers with names A, B, and C. So suppose you're writing a program involving circles and you would like to have the number pi be in your program. So here's how you might put pi into your program. Float pi, right? So first create a storage space for it, and then give that storage space the value of pi, or its approximation, right? Here's the 5 decimal place approximation. So you can take these 2 lines of code and do that in a single step also, like this. So float pi, oh, and by the way, pi has value 3.14159. Okay, so doing this, creating a storage space and placing a value in it at the same time, that's called initialization. Right, so this step right here is just telling the computer to set some memory aside for a decimal. You've sort of created an empty box, and then this line of code puts a value in that box. And here you're just doing it all at once, right? You call a box into existence and give it a value. So you can combine this slide and the last slide to do things like this. You can create storage spaces and give them values all in the same line of code if they have the same data type. So you can create 3 integer variables with those 3 values if you want to, all in a single step. Okay, so that's all the loose ends from last time, just shorter ways to write the code. Now let's move on to new data types. So we'll start with data type bool, which is short for Boolean. So a Boolean variable is not numeric. It is not created to store numbers. It's created to store one of these 2 values, either true or false. That is the only value a Boolean variable can take on. An integer variable can take on the value of any integer that's not too big. So it could be 3 or 17 or negative a million or something. You know, a Boolean variable does not have that many options. Only 2 options, true or false. To declare a Boolean variable, use bool. So write something like this, bool, and then give it whatever name you want, and you can initialize it if you want to. So you can initialize it to true or to false. But that's it. You can't give it any other value. So once you see a new data type, a natural question to ask is, well, why would you need that? It's sort of clear why you might need numeric data types, right? If you're calculating your numeric grade for this course or something, or calculating volumes or areas, why would you need a variable that can only take on the values true or false? Well, there are plenty of reasons why. Most of them we will see later, but for now, just consider this example. You're writing a chess program. It lets 2 people play chess. You could create a Boolean variable called game not over yet. That is either true or false. Either the game is over or it's not. And you could tell the computer that as long as this variable has the value of true, then the players should keep going, shouldn't they? If the game's not over, then they should keep going. But once somebody has won, or the game ends in a draw, you would then tell the computer to change the value of this variable to false. And that's when the computer would know, sorry, the second V should not be capitalized there. But anyway, once you change this to false, the computer would then know, oh, I quit the gameplay now, because the game is over. So that's just one example of how you might use something like that. Okay, next data type is character, or char for short. It's a data type for storing individual characters. So used for storing single letters or single symbols, like a percentage symbol or the at symbol or an apostrophe, anything like this. You use single quotes for this data type. So something like this would create a character variable called mychar, and you're setting it equal to or giving it the value of D. So mychar is now the letter D. Okay, so this data type, it should be fairly obvious why this would be useful, but useful for many reasons, particularly useful when you're parsing through a string of English, character by character. Imagine searching a paragraph for all vowels, for example. Or imagine that you're scanning through somebody's genome, right? So that consists of letters like A, T, G, and a fourth one that I forget right now, but a genome can be written as just a string of 4 different characters, and you might want to parse through that, looking for various bad genes, right? The Huntington's disease gene or something, I don't know. But in any case, being able to parse something character by character is useful. Yes, I mentioned this. You'll be annoyed by this. The fact that there's single quotes here, that will bother you, that C++ treats characters with single quotes. And it's not clear right now why that will be frustrating, but let me just apologize in advance. You will be frustrated by that. The reason single quotes is annoying is because you will get them confused with the next data type, which is data type string. So string is a data type for storing not just individual characters, but entire strings of English. So English phrases, or sentences, or paragraphs if you want, So you're storing not only just single characters, you can store single characters if you would like, but also just entire sentences if you want to. So when using strings, we use double quotes. Okay, so double quotes are for strings, single quotes are for characters. And so one thing that can be confusing, among other things, is that, so let's come over here. So I have char, mychar. That's a character data type, so I have to use single quotes. So now I could ask the computer, like, hey, what do you think mychar is, And it should tell me D. And it does, right? There's a D. Okay, suppose I didn't use single quotes, but double quotes. Now, the computer will be confused. I'm not sure if it will run or not. Yeah, it says no, right? There's a little red X over here. I don't understand this, is what the computer is telling you. You've created something of type character, but you used the wrong syntax. You were supposed to use single quotes. Okay, so a string, on the other hand, a single D is also a string of English. So if you want the character D now stored as a string rather than a character, you can. You just have to, use double quotes on that. So I'm asking it to print both mychar and myString. It should print 2 Ds, right? And no spaces between them because I didn't put a space in between. Okay, but with strings, you can now write whatever, I don't know. You can write strings of English. So there's a sentence. Right, so prints that first D from the character and then prints this whole string, right? So it knows that all of these characters make up this single string. If you tried to do that with the character guy, right? I'm not totally sure what it will do, but I doubt that it will be happy. Let's see. Oh, let's ask it to print. So let's see what it thinks it's doing. Yeah, so it says, well, look, mychar is a character, isn't it? It can only be a single character. So what it did was it just went to the end of this and stored that last E in there. It just ignored everything else, right? it's trying to accommodate you. It's trying to take this equal sign seriously, but you gave it way too much data. It can't handle more than a single character. Okay, so that's the difference between strings and character. One warning here is that cin doesn't work as you expect with strings. So cin works just as you would expect with anything else. So let's just declare a character, and then let's grab it from the screen. And let's see what the computer then thinks it is. So here's an example of using cin with a character variable. So I'm just going to enter a character, and the computer prints it back to me, right? It grabbed that character and stored it here, just like it would with an integer variable, and then it recorded it back to me. Let's do the same kind of thing with a string. Let's grab it, and let's see what the computer thinks about that. Okay, so hello, that's a string of English, right? The computer prints hello back to me. Okay, so that worked okay. It grabbed that word hello and gave my string that value, didn't it? Because when we asked the computer, what do you think my string is, it told us hello. Okay, so let me try that again. Hi there instead of hello. Oh, now the computer thinks that my string has value hi. It forgot about this hi there. Right? It didn't grab very much of that string. So maybe I can make this longer. Hi there, everyone. How are you doing? Now computer, grab that for me, right? Grab that string. It only grabbed the hi. So it's forgetting about a lot of stuff, right? It's not seeing a bunch of stuff. The reason this is happening is because if you use the straight up cin command, it will read until the first space. So the first space occurs right there, then it stops, So I'm not totally sure why it's programmed to act that way, but if you want it to grab the entire string, you have to use a command like this, get line and then cin my string. That doesn't stop scanning at the first space. It scans until you hit the enter key, so the enter character. Right, so now the computer grabbed all of that. So you see the difference, right? With just cin, it stopped right here, stopped reading right there. But when you say get line, it reads until you hit the enter key and stores all of that there. So that's how you have to actually use cin with strings if you want the entire string. So just to, again, emphasize this, let me declare a couple of strings. So let's cin, my string 1, cin my string 2. Let's see what happens here. So my string 1 and then my string 2. Let's see what it thinks about that. So I'm going to type hi there, everyone. Okay, so hi must have been stored in my string 1 because we know cin just reads to the space. But then the cursor is at the space, so the cursor is right here. So then when I tell it to grab the next string, my string 2, it reads the there until the next space and then stops again. So what it's doing is it's remembering where the cursor was. It's just going to read space to space. So if I added a my string 3 here, then I would grab everyone with my string 3. Okay, so just as a warning, right? If you want to grab from the user an entire sentence, you can't just use cin. You will have to use get line cin and then whatever you're storing it in. Okay, one other subtlety or obnoxious thing about cinning with strings is that sometimes you have to use the cin.ignore command. And to illustrate what that is, let me just show you how this works here. Okay, so let me just ask the user, like, what's your name? And then I'm going to grab their name from them. I'm going to store it in my string 1. And then maybe I could ask them, like, I don't know, how are you doing? And then let me grab their answer here and put it in the second string. So their name is going to go in my string 1, and however they are doing goes in my string 2. At the end of this, let's ask the computer what it thinks the values of these things are. Whoops. Okay. So my name is that. How am I doing? I'm doing pretty good. Oh, it grabbed it. Okay. Okay, good. Let me try that again. Okay. So this is actually behaving properly. Okay. So it doesn't always behave properly, and I'm not sure how to make it behave improperly to make my point here. But let me tell you what I thought might happen. What I thought might happen is you grab this first string, right? String 1 is David McCune, and then there's an enter key right here. And so sometimes the computer will take that enter key, this blank space right here. There actually is an enter character right there. You just don't see it. And it will take that enter character and put it inside of my string 2 right here. So when you ask it to get line right here, the cursor is right here at the enter key. So it might read the enter key and not move on. In this case, it behaved properly. It did move on, but sometimes it might not. So in any case, it's behaving well for me. So in this particular instance, I don't need this. But this might happen to you. If you're ever stuck at an enter key and it doesn't move on and read your next command or your next input here, you can use this command cn.ignore, and that would just tell it, by the way, move past this enter key. That's what you're telling the computer. If you see an enter key, just move on and read the next little bit of output. So in this case, since it's behaving properly, let's see what that ignore command does. Now the ignore command, since it's working properly, it ignores the W, right? It's moved past the enter key and ignores the W. Okay, but in any case, sometimes it works properly like it's doing for me now. Sometimes it works improperly. Sometimes it will grab the enter, in which case you need that ignore command. Okay, so let's clear this out. So in any case, using cin with strings is harder than with other data types. It doesn't work exactly like you want it to sometimes. So the last thing that I want to tell you is that a string is, of course, composed of individual characters, isn't it? I mean, a string of English letters, or a string of English is made up of letters and characters like a period or an apostrophe, things like this. So if you want to access an individual character inside of a string, you use a command like this. You use the name of the string, bracket I, where I is the character at position I inside the string. So consider this string, hi there, right? That consists of what? 8 individual characters, an H, an I, a space, and then THERE. So the way the computer thinks of this string is as these 8 individual characters, okay? But this is important, and this will annoy you, okay? So again, I apologize. It does not think of H as the first character. It thinks of H as the 0th character. Okay, let me say that again. H, even though it's the first character, is not at position 1, it's at position 0. C++, when it's counting positions of things inside of a list, in this case you have a list of characters, when it's counting position or keeping track of position inside of a list, it starts the tracking at 0. C++ starts counting at 0. 0 is the first number. So there are 8 characters here. The positions of characters range from 0 to 7. They do not range from 1 to 8. This is obnoxious, and you will be annoyed by this, and you'll forget about this, right? But those are the breaks. So let me just show you how this works real fast. So hi there. Now I could ask the computer, tell me, computer, what character do you think is inside my string 1, let's say at position 3? Tell me what character that is. It says a T. So let's count, right? 0, 1, 2, 3. T is indeed at position 3, just as it was in this chart right here, right? Position 3 is T. We could do position 5. And so again, position 5 actually means the 6th character. Oh, let me run this again. And it says an E. So notice position 5, there's an E, right? E is actually the 6th character, but since we start counting at 0, it's at position 5. Okay, so in any case, you can go inside of a string and grab individual characters if you want to by accessing them at their position, where they are. Okay, so to conclude this video, let me now just point out to you that you have 7 data types available to you now. The first 4 are numeric, the last 3 are not. Bool is for variables that take on values of only true or false. The character data type is for individual characters, and the string data type is for strings of English, so sentences or paragraphs or whatever. So at the end of this video, you should be comfortable with the basic syntax of these 3 variables, so how to declare them and how to manipulate them a little bit, keeping in mind that char and string differ among other things because char uses single quotes and string uses double quotes. And finally, you should know how to access an individual character inside of a string using this kind of command here. So that's all for this video.